Thanks, Jonathan, and thanks everyone for joining. I think we have an exciting topic ahead, so really looking forward to this one. So we'll be talking about AI in RGM. Of course, that's something that's very close to our heart because we as a company at Buynomics are also participating in it, I think with a specific view, and that's also something that we want to contribute here. So we'll be talking a little bit about different types of AI, differences between GenAI, Agentic AI, agent-based modeling, which is what we do here at Buynomics, and we kind of want to bring it all together so to really help you understand the topics. If you disagree with anything we say, that's of course okay. Please write it into the comments. We're happy to discuss all the different views at the end of the webinar, and ideally we'll all get a bit smarter in the process of doing so. So really looking forward also to your comments. I particularly like those that strongly disagree with what we say. I think those give us the opportunity to really sharpen our argument. All right, so without further, we go into the topic with a slide that in similar shape we've used a few times, because when we talk about a specific topic here now, GenAI, Agentic AI, it always makes sense to make sure that it's still a relevant topic. And a very straightforward way to do so is by looking at Google search trends. And here we have the Google Trends 5-year history of GenAI and Agentic AI. We previously only had it for GenAI. We just added the Agentic here. And I think there are different things you can see here. So that both topics really didn't exist 2 years ago, right? They quickly rose and are now predominant. And there are some other things. When you look at the GenAI curve, you always see these bumps at Christmas. So it's mostly a topic that's of professional interest, I would say. And what you can also say is that when you think, is it like a hype topic, or is it something that's real? It still looks very much like a real thing. So the interest in the topic is still increasing. So it's not something that came up and is then disappearing again. It really looks like this is a topic that's here to stay. And if you're in the topic here, I think that kind of makes sense as because of the potential that it has. I think what's interesting, and when we added the Agentic AI curve, is that you would expect it to be less relevant, but at least that was my expectation. But it has recently this year really passed in searches the GenAI topic. So at the moment, it seems to be the more relevant topic. And this is also why we want to put the focus there and really discuss the potential for us in RGM of the topic. So let's focus a bit more on RGM. And as you would expect, when you look for the topic, look what consultants, agents, all kinds of participants, conferences here, also looking forward to what will be said about the topic at the EPP conference here in Chicago, you see that everyone really has a view on the topic. Everyone discusses the potential, what's probably relevant, and probably I would expect that many of you have seen it recently. That's why we mentioned it here, the MIT report, that kind of sort of didn't necessarily put a roadblock in the road, but mentioned that many generative AI projects are actually failing. That they said that 95%, so most of them fail, and really go a little bit into the reasons behind that. If you agree or disagree with that, I think what's interesting for us is as a software provider is that the chances of success in a Gen AI project are significantly higher if they're done together with a partner who covers at least part of the solution. I think that's important. So if you want to tackle these, it makes sense to work together with the domain experts and really use their expertise. That was also one of the findings. I think that in the beginning many things fail. That's part of the game. But what's also important is that many of them succeed. And I think those are the projects that tend to be focused on moving forward. And also when we look at our track record, we're much better than a 5% success rate. So there's potential. It's not straightforward, but it's so in the sense that not always when you call something GenAI, or if you go there, you will be successful. It requires a lot of hard work. And that also, if we go to the next slide, is the case for Agentic AI. Oh, before we do that, I think there's one, sorry, there's one survey, just so that we can get your understanding of where you are in the topic. Tim, will you do that, or Jonathan, who will?
I think that's on Jonathan.
Yes, let me quickly pull up our first interactive element, polls and quizzes. Here we are. 1 second. Here it is. Okay, I'm launching the poll now. Sorry for the short delay. And for everybody joining by phone, let me read the question real quick. If you use GenAI in RGM, how do you use it? And we have the answer options: to interact with an RGM solution tool via LLM, to interpret results or analyze data, for research and ideation purposes, for all of the above. And then other, if you have something, please specify this really quick in the comments, and then don't use a GenAI and not answering. We are at 40% participation rate right now. Let's get this up to 65%. And then I'll share the results with the speakers and with the audience today. And we are at 60, so please lock in your final choices. And I'm ending the poll now and sharing the results. Ingo, Tim, what do you think?
Tim, you want to go first?
Yeah, interesting, actually. I mean, I would have expected that the majority is like not overall using GenAI, though I guess a lot of you might be using ChatGPT in your day-to-day work, maybe not directly for RGM purposes, but probably the overall use is much higher. And then seeing the other two results for research and ideation and to interpret results, I think these are great ways to use GenAI. So yeah, makes a lot of sense actually to me. What do you think?
Yeah, I would say the same. So, I mean, if we look at our work, I mean, interpret results, I think that would be probably a little bit less. But for research ideation, I think it's a good use. Result interpretation is, I think you have to be somewhat careful, particularly with complex results, in the sense that you always need to check if the interpretation is correct. But this is what I would have expected as well. All right, so let's get rid of it. Yeah, so as we then move from AI in general, when we then focus a bit more on agentic AI, and before we go and like our understanding or the definitions of the terms, we also looked at maybe now a little bit more with focus on consulting firms who've done surveys based on their projects, McKinsey, BCG, EY, for example. We looked at a broad range of these surveys and kind of aggregated the results from them. And I think what comes out when you look at agentic AI implementations or use cases, I think not all of them within RGM, but broadly in the commercial space. I think some of the learnings we want to take here. So I think what we already know from other things is that just the technology won't solve all your problems, right? So using the technology always requires redesigning your processes. So you need to be able to really use that technology properly. And that's, of course, also the case for something like agentic AI. What's also important, and this is what we will highlight a bit, is that you need the right tools for the right job. Just the AI agent won't solve all of your problems. If you just ask ChatGPT what's the right price for my product, there's a good chance that it won't give you the right answer to that. But it can, and this is what we'll discuss, use the right tools to come up with a much better suggestion. So you need to have the right tools, and the agentic AI or AI agent sort of orchestrates the different tools that are relevant. Some of them AI tools, some of them not AI tools. Also, what's important, and I think for most of us, I'm fairly confident that for the rest of our careers, the combination of human and AI partnership will be the dominant form and will outperform just pure AI agents in most relevant tasks. So there's, as we see it, there's a role for humans and there's a role for the AI part. And together they need to find like the right way to working with each other. And of course, with all of these things, it's important to have like the proper strategy and understanding to make it work in the organization at the end. So I think this is always important to keep in mind. So just adding an AI agent and hoping it will solve all your problems, that's I think not what any of us expects, but the research also confirms that that's not the case. So that was I would say the little bit of introduction before we now go much more into the details. And to do that, we want to start with a basic definition or like an outline of the understandings of the different terms. And for us, the key terms, and if you disagree, write it in the comments. We're happy to discuss at the end. At the end of the webinar. For us, the key terms are generative AI or GenAI as one concept, then agentic AI, and what we are adding and what we find important and very helpful, particularly in the RGM game, is agent-based modeling. What are the differences? GenAI as a foundation is essentially what we know as these language models or models that prepare graphics or other output. What they do is they sort of understand large sets of existing data, existing text, for example, to use insights from these to create new outputs. For example, to draft an email, generate specific images based on certain requirements. So they generate specific contents, but there's no agency involved, right? So you ask a question, it gives an answer, and the answer is based on some parameters, the proper answer to that question. Different from that, an agentic AI or an AI agent is, I would say, much closer to human reasoning in that it has sort of some objectives. So you give it much more broad instructions. So you would not ask it to write an email response to an email you received, but it would get the instruction to send out a certain number of emails or follow up with certain leads and measure how good it does. The agent does it based on some KPIs that you would also use to steer, for example, your business development team, right? So you would ask them, okay, I need to have 5 meetings in the next month that come from my AI agent, and then the AI agent would try to find the right way, formulate the right emails, right to the proper people to get to this result in the end. So essentially, it doesn't just produce an outcome, but it tries to follow certain objectives. And for that, it can use specific tools. It might use, for example, mass email tools or other things, but it really tries to achieve a specific objective. That means it has agency. That's where the name comes from, right? So, and it does that in different degrees of autonomy, maybe fully autonomous or within specific rules, right? So this is, I would say, the specific, the key difference. GenAI just produces outputs, has no agency about it, and an AI agent tries to achieve specific goals, and to do that, it can use specific other tools. We'll come to what that means in the case of RGM. Agent-based modeling, which is what we do here at Buynomics, and where Tim will go in much more detail, explain what that is, because this is really the focus of our work, is a little bit different from that. Also, the first name is somewhat similar. Agent-based modeling works in the sense that you create lots of these agents, and the different agents have also objectives. They have preferences. So in the case of RGM, what we call our agents would be, we call virtual shoppers. They have preference for different products. They have certain behaviors, how they react to price thresholds and other things. And you can use them to understand what happens when you make a price change or other changes, right? So you create many of these agents. They tell you how your product portfolio will behave in the end, but they won't write emails for you, right? So they're quite different. They're very narrow in answering the question of what products will be bought based on their trained preferences and so on. So I think this is a very important distinction. There's the AI agent who orchestrates certain activities to achieve a goal. The agent-based model, there are specific agents within that model. They have preferences for products in our case, and they make decisions. Do I buy this product or that product? Do I like a large coffee or a small coffee? Given the price difference, and when will I switch between the products? And the result is a very specific outcome, how sales, revenue, profit, and so on react to offer changes, which is essentially the core of our RGM challenge. So this is really I would say, the difference between the concepts. If we now maybe go a bit deeper on another poll.
Yes, we have another poll.
Jonathan.
I find it directly. So let me launch this. You're seeing the questions on your screen right now, but for everybody joining by phone again, if any, what type of AI are you using in RGM? And it's a multiple choice answer. So please indicate what AI types that Ingo just explained are you using in your org, in your daily work. We are at 35% participation rate right now. I give you another 10 to 15 seconds, and then I'm ending the poll and sharing the results with you. Thanks for everybody participating. Okay, last 2 seconds. Please indicate your choices now, and then I'll share the results. Ending the poll, sharing the results. Here we are.
Yeah.
The first thing is, I think it's good that don't use AI here, and no form of AI in the previous question is about both cases, like 35%, right? So that's very consistent. I think that's the first observation. And Tim, maybe you want to comment on the rest.
Yeah, I mean, absolutely. I think similar to what I mentioned earlier already. I mean, the point of that generative AI, most notably LLM tools such as ChatGPT, are mainly used here also in RGM. That makes a lot of sense. I think this is the currently still the main application for any type of AI, may it be in RGM, but also outside of RGM. Question is, is that the best thing to use in RGM, and for what to use it, that remains to be seen. I think we'll dive into that one.
Yeah.
All
right. So I think this is more like I would say a vision. I have not seen any company being there all the way, but I think the understanding of this AI agent is essentially something like this here, where you have human stakeholders, which is the RGM team. It's also the top management and other participants in the organization on the one hand. And the idea is that this AI agent sort of is in the middle, coordinates, as we said before, with the human stakeholders, but so in total coordinates all the different activities that are on the data side. That includes typically defining objectives together with the AI agent, in the sense that the human stakeholders typically define the objectives, but in practice, I think that it can be a bit more complicated, right? So there might be something like an overall company goal, and it's not straightforward how to translate that into a specific RGM goal. The standard example is that we always have is we're asked by a CEO, can the tool tell me what is the best way to increase net revenue by 5%? If you ask the CEO what you mean best way, then it's difficult to formulate what he or she means in that case. But this is a place where an AI technology can really help clarify what this like rough objective means specifically for RGM, including things like the proper trade-off between growth and profitability. So do you want to achieve a net revenue increase of 5% with higher or lower margins, for example? Do you want to achieve this with or without promotion changes or PPA changes? Do you want to allow to increase prices above certain competitors, right? There are many things that can sort of need to be made explicit, but are not always straightforward to make explicit for an organization. And here an AI agent can really help understand what's the RGM or pricing tradition of an organization. Has it historically always tried to avoid crossing a price, certain competitor price position, and so on. So this is what we mean that defining these objectives can also be supported by the technology, because it's for such a technology, it's much easier to understand what behavior or objectives have been relevant in the past. So doing this, really understanding all the different details, and then getting access to the proper data that's needed for RGM, internal data like margins, terms, and so on, costs, the sales data to understand the sales dynamics, and really have access to everything relevant, and then using the key models at the bottom here to really implement it. And this is, for example, where particularly the agent-based model can play a role in the sense that this is the technology in our experience that is best capable of predicting how demand reacts to price, promotion, product changes, and so on. So the AI agent sort of orchestrates all of that behavior, all of that functionality by using AI, for example, crawlers to collect competitor price research, to use the agent-based model to predict what happens, to use an optimizer to then find the best offer changes, and can even steer a TPM to then execute a promotion plan change, for example, right? So this is, I would say, roughly our understanding. And looking at the time, I'll hand over to Tim to not get into too much trouble. But happy to discuss. If you disagree, happy to go into more details at the end of the webinar.
Yeah,
Tim?
thanks, Ingo. And I think, yeah, this is a great slide, which really nicely shows like how these AI agents typically work. But coming maybe a little bit more back to RGM, and I think the poll earlier showed quite well that generative AI is being used predominantly for RGM. But what is it actually that RGM needs to answer, right? And the main questions that RGM needs to answer is around what's the right price, kind of the optimal pricing, what's the right promotion strategy we can run, the right mix and portfolio strategy, and also what happens when our competitors change something. And ultimately, all of these questions need to some degree be answered not by the AI that knows the most, which is typically GenAI. So typically large language models, they know just a lot of stuff, but rather by the AI that understands best purchasing behaviors. Because though, like based on the purchasing behavior information, you can actually, what will happen in the market if any price change occurs or any promotional change and so on. So just knowing a lot doesn't really help necessarily when trying to understand what consumers will do, because there we need to understand how consumer purchasing behavior works, how are their patterns and so on, which typically doesn't directly connect to Gen AI, but rather to agent-based modeling techniques, as Ingo showed earlier. And that's also what we have built basically at Buynomics, where we are focused on. We try to understand really how do shoppers purchase and why do they purchase like that. And for that, we've basically built this virtual shoppers AI, which is the fundamental model, the fundamental behavioral pricing model, and that is then being combined with data from the markets that we work with together to create what we call the digital twin of the market. So we basically use our model and train it with the market data so that all of the virtual shoppers, of which we create millions, do behave in the same way as the real shoppers do. So we essentially have a copy of the real shoppers then, on which we can then test what happens in the market if prices change and so on. And that's an insight basically that the GenAI can per default not create, because the GenAI will basically, especially a large language model, will basically just predict what's the next best word, and if it's price up, down, or keep the price, that remains like that depends solely on the context, but doesn't depend on consumer purchasing behavior. And how does this virtual shopper AI now work in or full-fledged in a way? So once we have these digital twin of the market, we basically, or what our algorithm does is it looks at the market always from like a value driver or an attribute perspective. So here in this example, 3 products, product A, B, and C. This can be these can basically be the entire category, like all of the products in a given category. And there's like the different value driving forces here. In this case, it's chocolate with different brands, flavors, and so on. And our virtual shoppers, of which there are millions, each one of them is individually calibrated for this market. So as also mentioned on the slide earlier, with agent-based modeling, we are not trying to understand, or we are not not modeling individual intelligence, but rather a collective behavior. And here in this sense, each of our virtual shoppers again is unique in a sense that they have a certain willingness to pay, what we call it, for the different attributes. So in this case here for the brand A, 75 cents, for the flavor nougat, 40 cents, and so on and so forth. And the entire, like all of these values together, they create the overall value of that product for this one virtual shopper. And if that's compared with the price, there's always a benefit or loss. And the same thing happens also for the other products in the market, always with a benefit or loss, in this case here 2 times a loss. And our virtual shoppers, they then buy according to their preferences. So they buy, for example, product A because they want to improve their benefit. That doesn't mean that they are rational. That just means that, for example, a small size compared to a large size is very highly valued by this one virtual shopper. So it doesn't matter the price of the large size product, they will always buy the small size. That still maximizes its benefit, but it's not necessarily rational. So we, like per default, can model this type of consumer behavior as well. And when then something changes in the market, we also know what will happen. When we reduce the price of product C, for example, we know that now the benefit is larger for the same virtual shopper, and we would, like the same virtual shopper would switch basically to product C. In the same way, if we introduce, for example, a larger size of product B, but kept the price the same, the benefit now for product B is the highest, so the same virtual shopper would buy product B. And that basically happens for each virtual shop. So the next one is unique. It has its own preferences, like all of the consumers have its own preferences. And in this case, that one would also buy product B. But since all of the virtual shoppers have their unique buying behavior, they all buy according to that. And we see a buying behavior of the entire population. And by that, basically, the buying behavior of the copy of your market. And here on the bottom right, number 7, I think that's a quite important one. There's always certain virtual shoppers, or in reality also certain real shoppers, that don't purchase at all. So that see a certain category, for example, in this case here, chocolate, and they just don't decide to buy. And these, of course, these shoppers can be pulled into this category with deeper promotions, with an enlargement of the category and so on. But in the same way, people can also move out of the category if prices become too high, if products become delisted that they actually wanted to buy. And this growing and shrinking of the category is a natural part of our agent-based modeling as well. So we see basically exactly that. And with all of that knowledge, of course, then once we have here on the left side created all these virtual shoppers, we can give them these different offers, as you saw on the slide earlier. So we can basically test different types of changes. And by that, then ultimately optimize here on the right side market share, revenue, profit, and have really deep insight into what will happen, what will our market or our shopper base do if we change, for example, the pricing. And I think that's the core of like this consumer or shopper behavior understanding is the core what is needed for RGM teams to actually make the right predictions. And then any type of other AI, such as a GenAI, for example, or an agentic AI in this case, can be layered on top of that and use this agent-based model to actually make better decisions, because just by knowing a lot, that's not enough. It would actually need to know the purchasing behaviors, and that would come from such a model as we have it developed. And I don't want to be only theoretical here, say only theoretical. I actually like to also show that now in the tool live. How does this look like? Given the time, I'll be a little bit quicker on this one, I think. So bear with me. And you should now be able to see my screen with the actual Buynomics tool on it with a trained set of virtual shoppers already in the background. And how does this work is basically if I now create a new scenario for myself here where I would like to test maybe a price increase, price change, just call it price here. And I jump into my, for example, iced tea market. Then I'm now able in this market, I see here on the left side in blue, if I'm the manufacturer or a brand owner, then these are my own products, these are competitors' products. If I now make a change, for example, to my prices, and I'm quite quick here on this one, so I will just take the first of my own products and apply a price change of, let's say, 5% increase and simulate that. And now it's simulating in the background. Then I can now see, after this price change has been progressed, how the virtual shoppers basically reassess their buying decisions, and ultimately how they switch between products and how they switch in and out of this category once the simulation is loaded. Of course, like here in this case, we can layer any type of change. So I did now a price change, but we can do product and promotion changes as well. And if we now select here the absolute deltas quickly, then we see it in granular form how the virtual shoppers actually behave. And again, here millions of virtual shoppers are simulated at the same time, where roughly 800,000 of the virtual shoppers leave this product because of this price increase, but they are not completely gone, but they move to other products in the own portfolio, here the blue ones, but also to competitors, here the red ones. And the total market is even to a degree shrinking. So there's a couple of virtual shoppers that don't decide to buy at all anymore at this point in time. So here is really the full understanding of the market, or behavioral understanding of the shoppers has flown into this tool and can then replicate full interactive market behavior based on any type of change that's available. And of course, the end game here is not necessarily doing this one change and seeing the impact, but rather optimizing for that. And for that, we have our optimizer developed, where we can then test a number of different, for example, pricing strategies here that then create this nice efficient frontier based on revenue and profit impact as an example. And we can now play out these two KPIs to find what is actually the right or what is the best strategy to pursue to get max revenue, to get max profit, or anything in between if we want to balance it out. And yeah, this is basically the application of this model and how the insights can be derived. And I think, again, what I mentioned earlier, GenAI mainly used in RGM so far, what we've seen in the poll, that's super relevant for certain tasks to get really to the core of the questions for RGM, which is basically what's the right price, what's the right promotion, and so on. Agent-based models are typically better suited from a core model perspective to answer these questions. And then generative AI can be layered on top for different types of interpretations or supportive functions, such like basically like an AI agent. Great. If I now go quickly back to our slides here, that was a really quick stint into the tool only. I would like to talk about a little bit about this, what I just mentioned, this layering. So basically what we have as the foundation is our virtual shoppers AI model, that's here on the left. And then the further capabilities can basically be improving the efficiency via a generative AI copilot that's layered on top, where the audience can, for example, interact with our virtual shoppers via this generative AI copilot, or let it interpret results, so similar to our first poll that we had, to just reduce time to interact via with a platform. And the other part is basically then automated optimization, so further automation here for any type of lever, may it be price, may it be promotions, or the portfolio setup. And I think this in combination then is a very, very strong setup for RGM, or rather for solving the main questions in RGM. Okay. I think last slide also, and then we drive or then we go into the questions. So like here the key hypothesis from our end, at least, on the future of AI and RGM. So I think one of the core things is like not all AI hype applies to RGM necessarily. So especially the point on, and as I've seen it greatly earlier in the poll, I mean the majority of people said here that they're using GenAI in RGM. That can of course have lots of different applications, and all of them are super valid. But not all of these AIs is necessarily needed to answer the core question of RGM. So certain parts, such as agent-based modeling, is. Others, such as GenAI, might be rather supportive function or a layered function on top of that. Second one here, agent-based simulations deliver real benefit. I think I tried showing that quite good on the slides as well as on the tool itself, but please challenge me also on that. And the last thing from our end, the future is a combination of AI approaches. That's really what I tried to say also earlier. It's like in the end, this this AI agent, needs to interact with several types of tools that can all do their works. Like a human being, we cannot do everything just by ourselves, just with our hands. We need tools to build something, or tools to interact with other people via, for example, here Zoom and the computer. And that's where these programs are very good in. And that's exactly the same in this world. So the agent needs the right tools to actually be able to make the right decisions and also help truly drive advantages in RGM. Okay, I think now we're at the point of questions. I try to stay brief. See you again, Jonathan.
Yeah, here I am. And we got a couple of questions, and I try to summarize some of them that basically tackle the same topic. We have a question from Pete, who is asking about the inputs. Are the virtual shoppers based on extrapolation of the actual conjoint analysis? And another question of how are the virtual shoppers created? What are the inputs needed?
Ingo, you want to answer?
No, go.
I can. Okay. So like the virtual shoppers are, or the input data that we use is predominantly market information, so sellout data typically, as well as product information, so product data, as we need to know the different attributes and value driving parts of the products. And that is in core the mainly required data. We can, of course, also use conjoint information as an example to train our virtual shoppers, or to, for example, combine several conjoint analyses to one bigger picture, which can be extremely helpful, especially if there have been a couple of conjoints being run in the past that are now seemingly useless, but combined with in a virtual shopper environment, they can actually be quite relevant. But predominantly, we base our training of the virtual shoppers on the actual market data, because we try to replicate what's really happening in the market, which is truly the market data, so what has happened in the past for real, compared to a conjoint where the results are rather from a sample and then in an experimental environment. So that's why we focus mainly on the sellout data.
Yeah, maybe to add, so there are, of course, the different methods, conjoint being one of them, looking at sales data and interpreting that is another. They all have, I would say, different advantages and disadvantages. They look at different things. Sales data is very good at helping us understand what really happens in the market, particularly also on long tail products that are typically not part of a conjoint. Whereas in conjoint, you have the advantage that you can look at things that aren't in the market yet. For example, a new brand, a new product feature. And what we can do is then combine insights from these different sources, and really play on the strengths of all the different ones. And just one last comment. Many of the things that you get from a conjoint, like dependencies between different attributes or product size and brands, for example, in terms of preferences, you don't need to run a full conjoint every time to understand these, because there are many commonalities that can be used and then to better understand the sales data. So what I'm saying is it can benefit from what we do from conjoints, particularly if there's something new that hasn't been in the market, but you don't always need to run a full conjoint, because we already know how shoppers behave from looking at very many conjoints, and many of these insights can be generalized.
Great, thanks, Ingo. We have another question. Let me pull this up really quick. Yeah, it's a little bit about the challenges and the barriers of scaling AI and RGM. We had a session with Colin some weeks ago on this, on his perspective, but maybe on yours as well. What's the biggest barrier of scaling AI in RGM? Is it the tech? Is it the data? Or is it primarily the culture?
Yeah, that's a great question. I think we did like a great webinar on that one as well. I think in short, it's typical. So what I see predominantly is not necessarily the tech. The tech is there. It's mainly workflows and behavior shifts. So teams that have worked for a long time with like similar tools that are used to, for example, simple elasticity studies or static elasticity studies. Since basically they started their careers, as this is a very old concept, for them it's much harder to like trust, let's say, into an AI tool. So I think changing workflows and changing the mindset towards the AI, that is relatively hard. But when it's achieved, then the payout is extremely high. Because the moment that shifts, that mindset, like many more applications will be found, because it comes suddenly from the teams like, okay, but for this I could also use that, and for the next one as well, and I have so many problems that I can now suddenly solve. That's at least what we see as the predominant factor for like lacking AI applications, but also on the other end on improved AI applications.
Great, thanks. Also looking at the time, and I've answered some questions already in the Q&A section. For the ones that we didn't get to, please get in touch with us, and we also try to get back to you and answer your questions. I sent the demo link already if you want to see a personalized demo. But on the next slides, we have other webinars upcoming that I also want to share with you. This is already, I posted this in. I think we can go to the next slide, and thank you. Yeah, a much requested topic, and I think it's currently in Q4 more important for many companies than previously in the year, is the topic of joint business planning. And we tackled this topic for the first time now, moving from negotiation to collaboration, how RGM leaders can future-proof joint business planning. And we have someone from Pernod Ricard joining us, as well as our principal sales engineer, Adam Hartnell, who has also spent some time at Unilever and Pernod Ricard as well. You can register now for free. It's our next webinar in exactly 2 weeks. I think it's then 3 p.m. and not 5 p.m., but it will be on the landing page where you can register. And a week later, I also want to share with you our annual Halloween special that we're doing now for the past couple of years. And it's always a nice mix between a humorous journey and some great pricing insights on pricing horror stories and what actually haunts your margins. So if you want to see what pricing mistakes we are encountering often that won't stay buried, you can register there as well. And these are basically the things. I also sent the survey we're currently running among RGM professionals. I've shared this previously on the Future of RGM report 2025 that we are launching soon. And if you answer this journey, you will get the report as one of the first ones, with all the insights and with all the data that we've curated over the past months handy into your email inbox. Yeah, and with that, I can only say thank you for everybody joining on this 1st of October, the start of Q4, and potentially the start of fall for real this year. And thanks a lot, Tim and Ingo, for those great insights. Really, really refreshing webinar again. Hope you all had fun and learned something, and hope to catch you in the next sessions. Have a great evening and talk to you soon.